Welcome, everybody. We are going to be working on the next playground here in Unit 2. And this one is starting with logical operators. And we're just going to work through this. So this is a lot of this, by the way, is repeat, right? So this is like refreshing your skills. And then a couple of new things are peppered in as we kind of go. Logical operators in programming are basically a way to set up statements to check to see how things compare to each other is really a good way to say it, right? So either things are the same or they're different, and or things can be greater than or less than or the same or not the same. All those things can be tested for by using logical operators. But ultimately, when we use logical operators in programming code, what we're really doing is we're comparing things to come up with the output of either true or false. Are these the same? True or false? Are they different? True or false? Is it greater? True or false? And then based on that decision, we're making some other sort of action. So really what we're doing here is kind of reviewing how that all works. We start first with the equals. So, and it's a double equal sign here. And now if you remember, like the first time you learned how to do any program code, we learned that when we use a single equal sign, that's not an equal sign. It's what we call an assignment statement or an assignment operator in programming, true in just about, I think, every programming language that I can think of. And then usually the adage is with a single equal sign, whatever's on the right side of the equal sign is being stored in the thing on the left side of the equal sign. That's how it works, whether it's an equation or strings or an object or whatever it is. The double equal sign was then used to determine equivalency. And let's just take a look at the example to start with. And if we put in 43 equals 53, right? We're checking to see if they're equal. Well, we know they're not, right? So, and that would output. So in other words, if I type this in, which I'm going to do in a minute here, that would result in false, right? And then if I just print false, I can force that to the screen, but they're also saying that you could put a logical statement inside of the print statement and it would still resolve to true or false, and then you could print it. So like the only way we're really going to find this out, of course, is to try it. But let's just follow their instructions here. It says for each of the logical expressions below, print out what you think the resulting value will be, then print out the actual expression to see if you were right. And so they're giving an example here. So the thinking is, what this result to? Well, we would print false, right? And then let's actually put it in there and see what happens. So our first one is 9 equal 9. Right? You notice how I say that. And when I'm doing a class like this, I often will say equal, or I'll say is equivalent to. That's really what the more formal correct thing is. So if I say 9 equal 9, well, I know that's true. The other thing that's going to happen, of course, in Swift playgrounds here is it's going to show us the answer before we even get to the next line. But we would print what we think it is. So let's just go ahead and kind of mechanically do this. Print true, because it is. And then let's follow their example of print 9 equal 9. And really, I think maybe the smarter way to do this, right, so we don't blow the answer, is that we comment out, like we don't actually type in what they're giving us. We just do the print statement and then the print true or false, and then print the actual results. I think that makes more sense, right? But here we're verifying that indeed 9 is equivalent to 9. How handy is that? All right. With this next one, is 9 not equivalent to 9? Well, I'm going to print, well, we know that's false, right? Or is that true? Well, that's false, because 9 is equivalent to 9. Let's test it, and we'll say print 9 does not equal. That's the exclamation. That's what the exclamation does, is it negates. All right. The interesting thing about that negation symbol, the exclamation point, is you can also selectively use that independent of the equal sign, right? So for example, if I had, okay, this is really a sidebar, but if I had, like, for example, a variable and I set it to true, right? And then I put an exclamation sign in front of that variable name, it would negate it and make it false, right? So, and you kind of can do that on the fly. Just mentioning it as a point of note. All right. I don't know if my Xcode is locking up. No, it's not. I think it's my mouse. Oh, yeah, that's right. I'm using a PC mouse on a Mac. So I'm reverse scrolling. It's like scrolling opposite what I'm expecting. I should probably switch it in the control panel. How about this next one? Is 47 greater than 90? Well, we know that's a print false. Right. So let's actually try it. We'll say print 47 greater than 90. And then indeed, it is false. Is 47 less than 90? Well, we know that that's true, so we'll say print true. And then to actually try it, here is 47 less than 90. Other, I think you guys know this already, but another thing I like to point out is, like, these spaces that we have around the logical operators are not required, right? You can squeeze those spaces out if you wish. All right. Here's where it gets a little bit weirder. Is 4 less than or equal to 4? It's got the equal in there, so it works.
Yeah, that's true.
Yeah.
Yeah, that's totally true. But you got to watch those when you're coding. And then of course we can test that. So you can say 4 less than or equal to 4. What about is 4 greater than or equal to 5?
No. False.
And then to prove it,
My Xcode has just been insanely slow. And I don't know why. Have you guys found anything that makes your playgrounds like work faster? Like anytime I type anything, it just locks up into the load wheel.
well,
Have you been?
Jonathan, I guess the first thing, okay, so we're recording this into the video, but it's a pertinent question, right? Because other people
Yeah.
that might watch the video would have the same question. I've had mixed reactions. So, like, when I first learned how to do Swift, I did it on a MacBook Air 13-inch with 8 gigs of RAM, and I think maybe a 250 gig SSD, like, kind of like bare bones system, but it was an M1 chip, right? And then as I was doing the training, my trainer was on an old Intel i5. And oh my God, we were compiling at like 3 or 4 times the rate that he was, just by changing the processor. So the first question I would ask you is, if you do an about this Mac, what specs are you pulling up? So you can see I'm on an M1.
Yeah.
16 gigs of RAM. So this is a school machine. They bought machines with a little more RAM at my insistence, by the way. And it's a 500 gig SSD in here, right?
Yeah. I have so I have a pretty nice Mac. So I have 32 gigs of RAM.
Yikes.
Yeah, so I bought this with the intention that this was going to be my workhorse. Like I wanted to, if I was going to invest in myself, I kind of wanted to do that. So so I was hoping that getting this, I would not have issues like this. But
What kind of CPU are you using?
M1 Max.
Okay.
You have the pro
So
models.
yeah, I was gonna say you're on a pro model then.
Yeah.
But
So,
yeah, go ahead, Jomar.
but my question is, have you restarted lately?
I mean it's been about a week.
Restart your system. That's probably what it is.
Yeah.
Yeah. So yeah, Jomar, I think you're onto some magic sauce there. All right.
Yeah.
So just to kind of, since we're like talking Mac here, right? And this is a pertinent discussion because, you know, this is specific to the platform. You can code Swift in other languages, but it is really a Mac centric thing. I mean, there is this thing that happens with Mac. Okay, so like if you're a PC user watching this video, you know, a lot of PC users don't leave their computers on overnight, and I've kind of do and don't, but sometimes I do get system instability on a PC and just rebooting. Or lately what I've been doing is instead of completely rebooting, I just sign out of my account and sign back in. And
Mhm.
what I've discovered is really the problem is in Windows, mind you, that Windows Explorer is actually unstable in Windows 11 with the last couple of updates they did. What might be happening on your Mac is you have other background services that might be kind of interfering with what you're doing here. The other thing that happens is when you're doing these playgrounds, sometimes we do write code that, okay, so the polite way to say it is doesn't release memory properly, right? So like in modern programming language, we have this feature that we call garbage collection. All right, so to give you this contrast, in the old days of coding in C, when I first learned the C programming language, and this is really old school. I'm talking like, you know, 30 years ago, you know, like that long ago, right? And what you would have to do is if you wanted to allocate memory for a variable, you would have to remember before you terminate your program to deallocate the memory, because otherwise the system would hold on to it. So it was potential that you could fill your memory registers. Now think about this. If you're running your playground and you've got all these variables and stuff going on, and then your playground locks up, the garbage collection piece of the modern language isn't executing and you get stuff stuck in RAM. Now, real frankly, Jonathan, a Mac with 32 gigs of RAM is like what most of us aspire to. Like we're like, yeah, you know, that's what I want 32 gigs of RAM. But it can also be a combination of the other stuff that you're running in the background. So like, you know, Jomar's suggestion of actually rebooting isn't a bad one. But it really, you know, I always say like on a Mac, it really shouldn't be necessary unless you're upgrading the OS, right? And that's true on Linux systems as well. However, stuff does get messed up when you're coding, because coding is the aspect of working with a computer that pushes your machine harder than any other thing that you do on it, with the exception of maybe gaming or video rendering, right? It's like those audio processing maybe too. But with coding, sometimes you write bad code and then that gets lodged in memory. And for as much as I want to admire xcode and all the stuff that Apple's done here, I think that xcode is still kind of a flawed program, right? Maybe one solution would be to upgrade xcode, but I think the option of maybe not reboot, but actually, if we go to a break, just sign out and sign back in, and you know, tell it to like relaunch all your apps, and you might make the difference. But also look at all your background programs. If you have Google Chrome, Safari, Edge, or any of the browsers that are built on the Chrome code base, Chrome right now has been known to be an extreme memory hog and not release resources correctly. It just depends on the websites you're visiting, and so that could be a culprit. But I would generally look at all the different things that you're running. If it's really that horrible, like even right now as we speak, it wouldn't take long for you just to sign out, sign back in, and pop back into Zoom, and you would be free to do that. But I think it's a pertinent thing to check. My experience though definitely is, you know, with an 8 gig machine, 8 gigs of RAM, I did see issues where it was sluggish when I was running too much stuff at the same time.
Okay.
The other thing to kind of think about is, do you have other Xcode things open right now, or is it just this one playground?
It was just the one playground.
Okay. Right. Yeah, that really shouldn't be happening. But if it does, my first go-to is just restart Xcode. If it
Yeah.
keeps recurring, then you got to look at the other stuff you're currently running. And then, yeah, Jomar's suggestion of like, unplug it and plug it back in again, or just restart the computer. It really amazingly does solve a lot of issues, but particularly like remnants of stuff that you're coding in memory that really aren't getting flushed correctly. That's usually the culprit. right? And it doesn't matter how much RAM you have. If the addressing system in your CPU, or your operating system thinks that spot's free and it's trying to write stuff back and forth and it's not working, yeah, you could see why it could cause a problem. It's kind of mechanics in the background. Real interestingly, I did go shopping this weekend, and we ended up at Costco, and I was looking at, I was walked by the Mac display, dreaming of that high-end machine I'll buy someday. And I was like, oh man, they got M3 chips out now. And I'm like,
Oh.
and then you start to feel jealous.
Well, funny enough, those M3s aren't actually all that much better than the higher end M1s. So if
Yeah,
you want to save yourself a little bit of money, just get a higher end M1.
yeah. Well, you stole the words from my mouth, right? Yeah, and that's kind of the same with like i5s, i7s, i9s. It's kind of the same kind of thing.
Yeah.
More cores does help, clock speed helps, but so does all the other stuff on your system, because it's all meant to work together, so now, of course, if I had to buy a brand new machine, I'd buy the latest greatest processor I could afford at any time. All right, let's keep moving forward. I think we haven't exhausted all the exercises, but now we're getting to the ones that are a little more interesting, right? So the ones above, I mean, you can look at them, go true, false, no, piece of cake, right? And I think you guys' brains are trained pretty well that way. But what about these, right? Okay, so let's talk about what this says first. Now we have, this is a logical and, right? And this is a logical or. So we have two statements here. This is a compound statement. What's the result of this one? All right, so I'm going to talk through it real slow. This is how my brain processes. Your brain might work differently, but the compiler reads from left to right, and so do our eyes, right? In the English language. So that's what we're going to do. And whenever we have a logical and, the big takeaway is this statement and this statement have to be true for the whole statement to be true. So and implies everything has to be true. So is 47 greater than 90?
Nope.
Nope. Therefore, the whole statement is false. Now, what I just did, notice, right? I didn't even check the second statement. That's called, in programming, we call that short circuit. And this is how most modern compilers work these days, is they're not going to waste the processing power to even look at the other part of the and, because it's already failed. Why would you look at the rest? Right? So the way the compiler would do this, it would look at this and go false and, okay, never mind. Doesn't matter what the rest is, right? It's kind of like you didn't get the touchdown, you're not kicking the field goal. You know what I mean? So you're not getting both, right? Because you already missed the touchdown, right? So if you want to verify that, of course, please, follow through with the process and do a print command. And then, of course, you can just copy the stuff from here, right? And just paste it in and save yourself the hassle of typing it, but just to verify that we are correct. With a logical or, this works differently, right? Only one of the terms needs to be true, or one of the statements needs to be true for the whole statement to be true. As we look at this, is 47 greater than 90? No. All right. But because it's an or, we got to keep looking, right? And is 47 less than 90? Yes.
Yes.
It is true. So this one is definitely true. Of course, once again, you can verify. And, I mean, you might find that to be a cumbersome process. No harm done. I mean, it takes all of like 3 seconds to do this. So may as well just to get the practice of coding it. And sure enough, it is true. Now, the one thing I will kind of say about ands and ors, right? Most often when we're using these, we're usually comparing two statements. But some programmers, what they will do is they will write really complex programming statements that might have like 5 ands in there, or 3 or 4 ors in there, right? And those are perfectly valid. You can chain them as far as you can kind of logically comprehend it, but the same stipulations are true. if I have like 6 statements in an and, well, then all of them have to be true. Where it gets weird, right, is if you're writing complex statements like this, where I might have like an or statement, and then I might wrap that in parentheses, put in an and symbol, and then put in another complex statement. It's an and or an or, and then it gets really deep, right? What I find that most programmers will run into as a problem is once you get past comparing 2 statements, it's really kind of hard to logically keep it straight in your brain as you're doing it. And then usually it's better, you're better off writing like if statements or other statements to accommodate for it, rather than trying. It's kind of like when you're writing an English sentence, like you can try to say everything in one sentence, or what you learn eventually is that sometimes it's better to have like 3 short sentences rather than one super long one, right? And your English teacher is usually happier about it too. But if you can conceptualize it, you can write them really long. I mean, that's the reality. All right, with this next one, here's the negation thing. So whenever we're putting the negation in front of anything, right, we're doing the opposite of it, provided opposite is possible, right? So usually it'll go in front of Boolean values or statements. So not true equals false, right? So we would print false. And of course we can test that theory. The one thing that I always have a little bit of a pet peeve with doing the negation symbol is, depending on how big your font is on your screen, it's really easy to mistake that symbol for the number 1 or the letter L, or you just don't see it, right? So like that would be one thing I'd be careful of. But that's a very useful negation. You know, when we just use the exclamation point and so on, it's very useful, and has a significant place in programming in my mind. All right, so that was the first page here. We're going to move on to if-else statements, right? And so why do we go from the logical operators to if-else? Because whenever we run an if statement, or what we call a decision statement or a selection point in a program, we are often having to ask a true-false question in order to make it execute, right? And so understanding the logical operators is key before you start doing logic that's true-false. All right, let's read through this first scenario here and see what they're asking us to do. And it says, imagine you're creating a machine that will count your money for you and tell you how wealthy you are based on how much money you have. A variable called dollars has been given to you with a value of 0. So you're starting out with nothing. Write an if statement that prints, sorry, kid, you're broke, if dollars has a value of 0. All right, so that's kind of easy, but let's go through that process here, and you know, if only to kind of recollect the process of writing an if statement correctly inside of Swift. So what happens is, you know, we learned this last semester, but hey man, it's easy to forget. So here comes the check. So I'm just checking if the dollars, here's the equivalent sign, equal 0, right? So this is what we were mentioning before. When you see a single one, whatever's on the right side of that equal sign is being stored in the item on the left, right? Here, when we use a double equal sign, we're checking for equivalency. And so that's going to resolve to either true or false, right? We already know it's true because we see it above. And then they want us to just output a statement that says, sorry, kid. Not realizing that we're all adults here, but whatever, right? So that's an example, and you can see that it's true. Now the statement's not resolving to true, but it's executing the print statement inside the curly brackets because it's true. All right. So now it says dollars has been updated below to have a value of 10. Write an if else statement that prints, sorry, kid, you're broke if it's 0, but prints you've got some spending money otherwise. And then let's see what's printed to the console. So what I'm going to do here is I'm just going to, you know, copy this part because this part's not going to change, right? So we're going to use the same if statement, but we're going to add the else to it. And the else you know, and kind of the swift way to do things, right? Is we put the curly bracket there and then start a new set of curly brackets here. And then we're going to say, statement. You've got some spending money, a whole $10. Woohoo! Right? That's enough to buy you that M3 Mac. Right? Yeah, not quite. But you can see now, because dollars was set to 10, the zero situation is no longer true. So it goes to the else to execute the code. Another thing that I don't know if you guys remember this, but Swift allows, if you're only using one statement in an if or an else, and I'm just kind of doing this as a matter of example, you don't have to have the curly brackets. Or do you? It's kind of an interesting effect here, right? If I, and I'm going to just kind of test this theory, I'm just going to cut this really quick. Is it still expecting the curly brackets? It is. It is, right? So I actually prefer it that way. Now, I'm not sure if this is just a glitch I'm having with xcode or if I'm not remembering the rule correctly. In most other languages, if you just do one statement, you can skip the curly brackets. And I thought Swift was the same way, but the compiler here is telling me otherwise. So I do stand corrected. So what I do tell people, like when I'm teaching them Java, is a really good example. And we get into those scenarios and I'm like, well, what if you add a statement in the if? You know, then you're going to be stuck in the aftermath adding your curly brackets. You're just better off having them there every time. So if Swift is enforcing this, I think that's better anyhow. Right. Yeah, you have to type more code, but whatever. All right, let's move on to the next one. All right. So now what we're going to do is we're going to add a else if into the mix here. And basically what we're going to do, it says dollars has been updated below to have a value of 105. You know, write an if else if statement that prints, sorry kid, you're broke if it's 0, prints you've got some spending money if it's less than 100, and then prints looks to me like you're rich otherwise. Right. Any otherwise is kind of a fancy way of saying else. You know, that's kind of like the terminal else. So what we're going to do here, once again, is we're going to copy our code from above. Yeah, don't retype it. No point in doing that. And then we're going to turn this second statement from an else into an else if with a condition, right? So as soon as we add the word if in there, we need the condition. And this time we're going to check to see if the dollars are less than 100, right? And then we're going to say you got some spending money, and then of course there's the final else. And what was the message they wanted us to use? Looks to me like you're rich. Okay, so I wouldn't call $100 rich, but hey, it's all relative, right? Try to keep in my mind that there are countries on this planet where sometimes the per capita income annually is not even that much for some countries and some people in some countries, and that's crazy to think about. Right. All right. Now, I do want to talk about the logic flow of this a little bit, because if I just omitted this part of the if statement, the part I just highlighted, and I just said if dollars are less than 100, right? 10 is less than 100, 0 is less than 100. And I had the number, you know, one of those numbers in there. Would this statement trigger? Well, yeah, it would. But this is the part that kind of catches people, because if this runs and this is true, if it's equal to 0, yeah, kid's broke. If it's less than 100, right? Well, then, yeah, you got some money, but it's not really a lot. And then otherwise, this will just print either way, right? So you guys remember how the ifs are working. But wherever you see that keyword if, you got to have some sort of a logical test with a comparison operator or some sort of a Boolean statement. something that resolves true or false in order for it to trigger. And that's really kind of the main takeaway of this particular playground page. All right. I'm assuming you guys are good, so I'm going to move along.
Yep.
All right. All right, so now we're at one of the exercises. So this will be one that is for points, right? So if you look at the assignment description for this playground, this is one of the included ones. And it says, these exercises reinforce Swift concepts in the context of a fitness tracking app, which we were building last time, if you guys recall. It says you want your fitness tracking app to give as much encouragement as possible to your users. Create a variable called steps equal to the number of steps you guess you've taken today. And, I have this thing called a smartwatch on my wrist here, which is kind of interesting. Oh, that can't be right. I'm looking at it and go, I wasn't wearing it when I took my dog walk this morning because I actually took a pretty long dog walk. So it's listing me as only 300 steps today. That's a very lazy day for me so far, right? I generally try to clear 5,000, by the way. And I usually do. Sometimes we're just walking around Walmart for a couple hours. All right. It doesn't even take that long, actually. All right, so let's build what they're saying. So variable called steps, and they want us to throw a number in. Okay, so I'm just gonna throw a number out there because this is where I'll get to by the end of the day. 4,928, just shy of my 5,000 step goal, right? Next, they're saying create a constant called step goal. So constants, remember, we start with a let, and then we're going to say step goal. And our goal is going to be 10,000. Why? Because that's what they told us that it is. Right. Then we're going to write an if statement, and it says write an if else that will print you're almost halfway there if steps is less than half of the step goal. Right. So we got to figure out the math on that, and we'll print you're over halfway there otherwise. All right. So let's do the logic on this. So if I write an if statement here, I'm going to say if what? And think about this. If your steps are less than, we want to say half of the step goal, we can just do the math right here in place, by the way. So I can say step goal divide by 2. Just do the math right in position, and that will execute. One other way to do it is you could create another variable or constant with the result of the calculation and then check that, but that's wasting memory. That's the way that a Apple developer would look at it. All right, so we're supposed to print that's true. So if it's your step goal divided by 2 is greater than the number of steps, you're not at half yet. So you're going to say you're almost halfway there. And let's be positive and throw an exclamation. Otherwise, I'll put the other statement, which is you're over halfway there. And then, of course, you can, think about this. You can extrapolate this out. And if they reach their goal, you could write a else if and, and kind of get it there. But this is all we were asked to do at least at this point. Right. Well, you can guess what's next, right? So, and what we're going to do here is we're going to copy our existing if statement as it is and just drop it down here in the next block of code. And then let's read the instruction. It says now create a new but similar if statement that prints way to get a good start today if steps is less than 1/10 of the step goal, prints you're almost halfway there if it's less than half, and then you're over halfway there if it's greater than half of step goal. But now the question becomes, what is the order of those? And here's kind of what they're really trying to point out here is I wouldn't add the else if for the smaller increment to happen after this check. right? Because if I check to see if we're less than halfway there and we're only 10% of the way there, well, that's going to register true, and that the 10% thing would never kick in. You see the point? So when you structure these if statements and you're checking a range of values, you want to either order them from smallest to largest or largest to smallest, one direction or the other, right? And I think that's kind of the grand takeaway here. So the initial if statement, well, I'll kind of leave that alone, but I'm going to come up here and start fresh. And I'm just going to say if steps is less than step goal, but this time divide by 10, so a tenth of the way. Then we're going to say, what's the message here? It says, way to get a good start today. Way to get a good start today. Right now, that's what my watch is telling me. Right now, we want to continue this part though as an else if, so you can just basically move it and add an else in front of it like this, and now we have what we're looking for. So we catch the 10% first, then we catch the half, then we catch the over half. All right, you guys get that to work?
Yep.
All right,
Still typing.
still typing. All right, I won't change screens too fast, then I'll give you a second to catch up. But you know, kind of like the thing I always tell my students is like, if I'm moving really fast, because I sometimes do that, and I apologize if I am, there's always that screenshot too. You can always grab an
Yeah.
image of it, or you know, just a helpful tip. We can always you can always watch the video in the aftermath, right? But you gotta like wait a day until I publish it or whenever I'm not busy, basically. But yeah, that's the thing, right? So you can just screenshot it and copy from there. But you know, the key is here that we check to see that it's working. Really, the only way to properly check that it's working is to try all the different like numbers, right? So I just changed this so it's under 10%. So the 10% is catching. And then I have, you know, those days where, you know, I walk a lot. There you go. And interestingly, you know, like I intentionally take long walks often, right? So I always usually clear those 5,000 steps and usually 10,000, you know. But if I have like one of those days where I go to like Summerfest or something and I'm on my feet all day long, I've sometimes gotten totals as high as like 25,000 steps. And it's like, whoa, you know, how many miles is that? It's a lot of miles, right?
Also, I'm good.
All right, excellent. I'm moving on to the next one, folks. All right, so now we're gonna keep, you know, kind of working on this Boolean thing here. And let's just kind of read through it. It says, imagine you're going to a dinner with friends and you're struggling to decide where to go. Two of you have very strong opinions and have clearly laid out your requirements for dinners as follows. You want to eat somewhere that either has fish or pizza, and your friend wants to eat somewhere with vegan options. All right. Another friend brings up a restaurant she thinks will fit both your criteria. This restaurant's attributes are represented by a few constants below. Write an if-else statement that will print let's go if the restaurant's attributes match the group's dietary requirements. Otherwise, we'll print sorry, we'll have to think of somewhere else. Right. And so this is kind of a goofy little exercise, but it has you think about, this is really kind of a good Boolean exercise because it has you think about these stipulations. And I don't know if you guys maybe have a family that's like this, but I have a family that's like this, where I'm a meat eater, nobody else in the family is. And some of the people in the family will eat certain foods and even, you know, they're vegetarians, and some will eat other certain foods or not eat certain foods, you know. So it's always this kind of like if you're going to go out to eat, it's kind of a struggle to find a place that works for everybody, you know. And you know, that happens even if you don't have a restricted diet. But I will warn you guys, as you get older, either by choice, logic, or health, you often restrict your diet. You know, like one thing I tried to never do is have soda, for example. You know, not that I don't like a good Coca-Cola, but I used to drink like several of them a day, and now I don't touch them. You know, And it really does make a difference, by the way, on your waistline. But if we're going to do this in terms of going to a restaurant, let's think about this. Well, we know it's going to be an if statement. So now the question is the two criteria above, and I want you to look at how it's worded, right? You want to eat somewhere that has fish or pizza. The keyword or is there. So there's a logical or in play here. And your friend wants to eat somewhere with vegan options. Not that they're going to make those options, but they want to eat somewhere that has them, right? So this is a compound statement here. So let's get the first part. So I'm using parentheses here to make sure that I keep this separate. So I'm going to take first a look at the variables that, or excuse me, the constants that were set above. And I want you to notice both how the constants were named and the values that were applied, because these constants are holding Boolean values. We also name them in a way where it kind of asks the question. So for example, has fish, if you say it like that, like a question, true, right? Has pizza, false. Now, why would they set that one to false?
Maybe the restaurant doesn't have a pizza option.
Well, right. They picked a place that doesn't have pizza.
Yeah.
They picked a diner, no pizza at the diner or whatever. Has vegan, true. Okay, so those are the features of that restaurant. But in terms of writing the statement, the reason I say that is because often when you see like has or is as like prefixes to constant or variable names, it's because they are Booleans. Remember that when you're in xcode here, or the playgrounds, that you can hold on the option key, right? See it change into a question mark. You click and it'll tell you if it's a Boolean or not, right? So even in spots other than where it's declared. But here we're going to check to see, does it have fish? Or those are the pipes. That's the shift of the backslash key right above your enter key. Does it have pizza? Now we know one's true and one's false. So the statement is true. You guys feel what I'm saying? So that's an or, it's inside parentheses because that's exclusive from the other part of the statement. And not only does it have to have either fish or pizza, but it also and must have vegan, so it has vegan. So we need it to have vegan options to be true, and then either fish or pizza to be true for the whole statement to be true. But this is a really good example of a compound statement with an or and an and. This isn't a super complex one, but you can see how that's pretty efficient because you're testing a lot of things all at once, and it's all about how you convert it logically. So if that's the case, we're supposed to print. Let's go. Sounds good. Let's go. Okay. Otherwise, we'll just put a message on the screen that says print. Sorry. And if you guys are like me, often what happens is when we get to the point where we're thinking of somewhere else that ends up being home, right? Because it's cheaper and better usually anyhow. But all right, so there's the first part of it, right? But now, of course, you're going to throw in a wrinkle, all right? And they're doing this in the form of a nice, different kind of equation here. So here's our other scenario. It says, imagine you're trying to decide whether or not to go on a walk. You decide that you'll go on a walk if it's not raining, or if it's 82 degrees or warmer and sunny out. Now, think of all the terminology here, right? And you got to be careful with how this is placed, right? Because it's all in the description. Create a constant is nice weather that is equal to the expression that evaluates to a Boolean, indicating whether or not the weather is nice enough for you to go for a walk. So what they're having us do here is first develop the Boolean statement and then store it and then check what we stored. You see the difference here. And I sometimes when I'm coding, I like to take this approach better because it helps my logic. And more importantly, it makes my if statements look cleaner, you know? So this is what they're telling us to do. They're saying to create a constant called is nice weather, right? Now notice is the prefix, right? It's kind of like asking the question, is it nice weather or not? True or false? Right? So it kind of implies that it's a Boolean right there. And what we're going to set that to is if it's not raining. Okay. So the way I would say that in code, of course, is we're going to negate is raining. So we're going to say not is raining. That's kind of what we would say it. But it's kind of like saying it's not raining, but not is raining. Right? Because that's one thing. So it says you'll decide you'll go on a walk if it's not raining, or, so now we're going to put in a logical or here. The next thing sounds like a compound, right? And the compound thing says, or if it's 82 degrees or warmer and sunny out. So when I say 82 degrees or warmer, that's like saying the temperature is greater than or equal to 82. That's how I read that, right? You might not read it that way, but it's all in how you read it and understand it. And this really kind of goes back to one of these fundamental precepts of programming is whenever you're programming, you're coming up with a solution to a problem. You can't come up with the right solution if you don't understand the problem clearly, right? So I'm going to check to see if the temperature greater than or equal to 82. Now, I'm a Wisconsinite. I would lower that threshold probably down to like 65, you know, for maybe even like 45, honestly, because I still do long walks in the winter, but whatever. We're a little hardier than most, right? The other thing that we're checking against is it's sunny out. Now, these values are preset above. So the temperature is preset. The raining, is it raining? Apparently it's raining. And is it sunny is true. Makes no sense, right? But it is possible it rains and there's sun out at the same time. Just putting it out there. All right. So what this is going to do now, and you can see in the sidebar here that the statement's evaluating to true. Do we agree with that? Well, is not raining true? Well, if raining's true, what is not raining? False. Right. So this part is actually a false here. So what I'm saying, folks, is like this. Like if we get rid of this part, what does this evaluate to? False. Because up here it's set to true, and here we're negating it, so it becomes false. Right. So you guys are catching that. Okay. Then we're saying an or. So this part's false. So in terms of an or, so far the statement's false. Right? So that means when we hit the or, we got to keep evaluating. Now we're evaluating a compound statement. So if the compound statement evaluates to true, the whole thing is true. So let's check. Is the temperature greater than or equal to 82? Yes, that's true. It's equal to 82. And is it sunny? Well, yes, it's sunny. So both of these are true, which they must be for it to evaluate to true. So this side of the or is true, meaning that this evaluates true, which we see in the sidebar, right? So just to follow the logic on that. This kind of logic takes a little practice, right? And it's not intuitive for people that have not done this before. It's really easy to flip your logic backwards. You know, so if you have a complex statement like the one that we're just building right now, one thing that you can do is you can break it apart into little pieces and just see if it's true or false. Right. And I find that that's really helpful. Right. So here we are, we're evaluating whether it's true or false, and we're evaluating that it's true. Right. And we're storing it in a thing called is nice weather. And the answer to that is true. Now we have to write an if statement. So instead of taking all of this and checking it as an if, which we could have done, we're now just going to check the stored value is nice weather, which we know is true. And then we're going to print I'm going for a walk. I can see that it worked. I'm assuming you guys are okay at that.
Yep.
I think that's a nice one to practice, you know, Booleans, logical ands and ors, and negation all at the same time. I like the fact that it's being demonstrated that you can check the logic independently and store it, right? Because, okay, now you might ask, like, why would you do that? Well, maybe there's another spot in the program where we need to use the same true or false. Would you want to reevaluate it if it's already evaluated? No, right? So there can be efficiencies by storing it, especially if you're doing it over and over again. All right, let's move on to the app exercise. So this one's also for points, right? So this would be a deliverable for you guys. Going back to the fitness tracking app, that's kind of like their thing here, it seems. They're giving us some information, and then they're asking us to write some code. All right, so the point here is that we want our fitness tracker to have a feature that helps users stay inside a specific heart rate zone when they're working out. We want to put a message telling them to go faster to increase their heart rate if they're below their target, or that they're spot on, or to slow it down a little bit if they're pushing it too hard. Once again, our smartwatches kind of do this, and I think this is kind of interesting, right? You know, like if you're a smartwatch wearer, that you can have your watch do all those things. But we're going to create some constants in here above and below what is listed here, but they have some presets. So let's look at the preset ones. So we have a target lower bound, an upper bound, and a current heart rate. So it's the upper bound of the heart rate, so that we don't want to go over 150, but we also don't want to go below 120, you know, because then you're just kind of sitting around basically. All right, so those are kind of our givens. Now we want to create additional constants here, named as follows. So the first one is let, and now I'm looking at, they want us to do three of them. Is in target, is below target, is above target, and for whatever reason my brain tells me to do below, above, and then in that order. But maybe, or maybe actually it should be below, in, and above, right? Like as a range. So that's how I'm going to order them, different than what's listed above. And then what we're going to do is we're going to use a logical comparison here to populate these. So let's think about this. If, you know, they're calling them constraints. Okay, so they're saying create constraints, is in target, is below target, is above target, that equal expressions that evaluate to whether or not the current heart rate is between the upper and lower bounds, below the lower bound, and above the upper bound, respectively. Right. So some of this I think makes sense. So if you're like below the lower bound, you just take your current heart rate and say current heart rate less than lower bound, right? It's the in target one that's kind of the difficult one. So let's just kind of do these one at a time. I'm going to go is below target is the first one. And what I'm going to do here, and maybe it makes sense to maybe put a space in here, a blank line. Now I'm going to say that okay, so if we're below the target, the current heart rate is less than the target lower bound. So less than 120, basically. Then there's the other side of it, which is let is above equal. Well, you know what? Isn't that exactly the same thing? We're just going to flip the sign. Yeah, we could, yeah, absolutely. So we're just going to copy that and then put the sign on it. Right? So in this case, we're going to be heart rate is over, but not the lower bound, the upper bound, or 150. So those are pretty easy. Right? We check to see if it's above or below. We store the true or false. Right. But we got that other scenario, and I'm putting that one in the middle because logically in my brain, that's where it sits. You know, below, middle, above, whatever. If your brain might not think that way, but mine does. So I'm going to say is in target, and you could even say range, I guess, but it's in the target range here. And how would we know that logically? Okay, so just think about this, right? And this is a common sense thing, and this is how common sense plays out much more easily than writing it into code, right? So the common sense says, well, if I'm in range, that means I'm above the lower bound, right? And I'm below the upper bound. And if you listen to just how I said it, there's greater than or less than in the mix and an and in the mix, right? You catching how I'm saying that? So the statement is basically built like this. We'll just say the current heart rate is greater than or equal to, arguably, the target lower bound. So that's the lower end of the scale. And the current heart rate is less than or equal to the target upper bound. So you see how that's a compound statement. And once again, how our brain really easily kind of puts this logic together, because we see a upper, a lower, and an in between. It's in between is like it's in between. That's how we think about it. But to do it in code, it's a lot more complicated when you break it down into little pieces. And this is the challenge of coding, right? What's intuitive to our brains isn't necessarily as clear when you really break out the details of it. This is this is a way of saying in between. And so I think that's important. All right, let's now write some if statements. It says, then write an if else if statement that will print you're right on track if they're inside the zone, doing great, but try to push it a bit if they're below, and you're on fire, slow it down just a bit if they're above, right? So let's start by just checking, and we're going to write it, I think, not necessarily in the order that they're saying. So I want you guys to think back to what I just said just a little while ago in terms of if you're writing if else if statements and you're checking values, remember like the 10% and the half thing, right? If I would check the half thing first, it would be true, and the 10% thing would never register. Here it's the same kind of thing. We have to start either at one end of the scale or the other and work the other direction. So I'm going to start at the bottom end of the scale. So I'm not going to do what they set up top. And this is what the trick is, right? You think that you're going to write an if statement that says you're right on track if you hit the target zone, right? But that's not the smart logic here. The smart logic is to check, is it below the target first? And notice, because this is already a Boolean value, right? Because think about this, anything here that's got a comparison operator is going to store as a Boolean. You're not sure about that, do the option click and you can see it's a Boolean. In fact, all of these are Booleans, right? So I don't need to write anything aside from is below target. Remember, is the prefix is the question, is it true or false? And so is it below target range? Then we're going to just output something like this. We're going to say, doing great, but try to push it a bit. That's a polite way to say you suck, basically. Right? It's like, come on, you're doing great, but they're trying to be positive. Okay, so we'll give them that. Then we'll check the middle of the range, right? And so we'll say else if is in target, and we're going to print out the message. We're going to say right on track. I like to use those exclamation marks. Then finally, we need an else to check this. And I don't know. Here's a question. Is it a straight else?
No.
Is it a what?
Could I just use else here, or do I have to say else if?
I want to say else if.
Yeah, and
You can do, huh?
I think you can do it either way. It's my
Yeah.
and now what the authors of the book did, right? Because I'm looking at their solution right now as I type this. If you think I'm all brilliant and stuff, not that I couldn't figure it out, but I like to look at their solutions to see like how they approach stuff and to make sure I hit all their teaching points. But they're doing it like this, right? So they are writing an else if. And I think mostly because we actually wrote a like code here that's testing whether it's true or false. So that I think they're just using it basically. So we're supposed to say you're on fire, slow it down a bit. So, oh, I forgot to put the condition in here, which is above target, like so. And which one's going to trigger? Well, the current heart rate's 147, so you are on target. If I change that to 157, you're on fire, slow it down a bit. If I change that to 107, now we're below range. You're doing great, and you can see the output, right? But if I switch this back to the 157, which is above, right? And I remove this if, right? So I'm just gonna cut it. Still evaluates the same. This is kind of interesting. Now, if I was writing this code and I was going to write the program for distribution, and I'm just putting this out here, I wouldn't do another logic check here. Why? Because it's not necessary. Doing the other logic check requires that we go into memory, look at the value, check for true and false, and then execute the statement. Since the other two scenarios didn't hit, this third one will hit without any checking. It will make the code run faster by eliminating what I just pasted back in. So these are the goofy little things that you think about as a programmer. I will tell you, in modern programming, thinking about this stuff is for many people out the window because we have so much RAM and so much processing power. In the old days, we would think about every single thing that we're checking.
I need to be right back. 1 minute.
Okay.
Thank you.
I think we're going to take a pause here. Anyhow, let's take a break.
Okay.
All right, back from our break, we're going to work on this next page here, and we're going to revisit switch statements. If you recall, like one way we make decisions in programs is we do if and then else if, and often what happens is if we have a significant series of else if statements, it's like, and for me, it's like once I get past like 2 or 3 or 4 of them, then I start thinking, well, maybe I should use a switch statement instead. Now, this is something that we've learned before, and we were doing the app builds from the last course. We did play with switch statements. But switch statements are particularly useful, by the way, when we're working with certain types of data structures. And I don't know if you guys recall this when we did the, I think it was the element quiz and maybe even the other one, where we have stuff that's placed into an enum, where it's like these predefined types that we're working with. A switch statement was built really to work with that stuff. And it's also, I think, a more elegant way to do an if statement, because the syntax is cleaner. There's a whole lot less syntax that goes with it. All right, let's read the scenario here. It says, you're on a baseball team nearing the end of the season. Create a league position constant with a value of 1. Use a switch statement and print champions if you're in position 1, runners up if 2, third place if 3, and bad season in all other cases. All right, so let's do that. Let's get the constant in there. We'll say let league position equal 1. So first place. Right. Here's my switch statement. So we're going to say switch. And what's the thing that we're looking at for a value? We're looking at league position. Now, in this case, this is an integer, right? Can we be sure? Yeah, just always use this option click trick. Yeah, it's an integer, right? And we don't have to write complicated logic. We're just checking to see, checking this value, and then we're going to check against the range in the case statement. And that's why the case statements are so nice, I think, in my opinion. So we're going to check the case of number one, and then we're just going to say print champions. What if you come in second? So we'll say case 2 colon. And I think it's kind of interesting, as I type this, how when I press enter, I'm indented, but the moment I type case 2 and then put the colon in, it moves it out to the margin, right? I didn't do that manually, by the way. So in this case, we're going to print, what was it? Runners up. That's almost a winner. It's 3. Third place would be what we print here. Spelled correctly. Oh, I see. The third place doesn't get an exclamation, nor does runners up, but champions gets an exclamation. You guys catch that?
Yeah, I saw that.
Yeah, runners up. Third place. Right. I'm injecting a little bit of a slight emotion to it. Now, the other scenario that they threw in here was this thing that, you don't always have to use this, by the way, but it's the default, right? Doesn't check the case at all. But if the league position doesn't match any of the other scenarios, then this will kick into place and it will print. Bad season, and that one gets an exclamation. Tells us something about the author here. Now the interesting thing about this, and doing a language comparison here. So a lot of times when we're doing this in other languages, you do a switch case statement, and it very, very similar terminology and approach. But for example, if we were writing this in Java, every time a case would execute, we'd have to throw in a break, right, to jump out of the switch statement, right? And for example, this is what we would do in Java. We'd like break, semicolon, and then it jumps you out, right? Because otherwise what happens is it keeps processing, right? Here that happens automatically. You don't have to do that with Swift, right? So if you're doing a language comparison, and I think that's pretty pertinent to know. So that's not necessary here. So I appreciate that it just happens automatically. Now they're also kind of doing this other thing here at the bottom. It says write a new switch statement that prints medal winner if league position is within the range of 1 to 3, otherwise print no medal awarded. And so we're switching then again on the same thing is really what they're telling us. So we'll do another switch once again with league position. And this time we're going to declare a range. So and this is how you do this. So if you are working with integers at least, and our range would be you start your starting value and then a ... 3 dots, and then the range you're checking up to, which is 3. So anything in that range will trigger this. Print. It's in there, medal winner, right? And I'm not putting any exclamations in there. Sorry, author. Right. Otherwise, and once again, here's the default. This will execute if they're not a medal winner. We're going to say print no medal award. That we should be a medal winner if we're in first place. Now, of course, you can check these scenarios, and this is kind of the recommendation. Change the value to 2. Does the second case catch in the first switch statement? Are they still a medal winner at the bottom? Right, they are. If we change this to 3, does it move down to third place? It does. They're still a medal winner. If we change it to fourth place, they're just losers. no medal awarded, bad season. And you could put a little thing in there, you're a loser, you know, and lift everybody's spirits. Right? But that would be the suggestion, is that you do change the values. Now, here's kind of a weird scenario. What if I put in a floating point number instead? All right, so I put in 12.
Would it work if it's a range, but not work if it's like a normal case?
Yeah, so here's your answer, right? So I put in 1.2. Up above, it's not matching one exactly, so it's a bad season. On the bottom, it's in the range, so it's the medal winner. Interesting, right? But the switch statement is built really to check the data type, that's implied there. In this case, the number one is an integer. If I wanted it to check a floating point value, I'd have to list that floating point value. Or if I wanted it to check a string, I'd have to list that string. But that's a good experiment to do, so you can kind of like latch your brain onto how those switch statements work. This is once again repeat for us, right? So we've already learned this stuff. I don't know if like the first time around, first semester, we did any ranges. I think we talked about it really quick, but I don't think we coded any of them.
Yeah, I don't think we did any ranges.
Yeah. A lot of languages do have those, by the way. What some also have, and I don't know if Swift does this, but in Swift, what happens is we do get multiple values. So instead of declaring a range, we can also do comma separated values. So I could do like 1, 2, 3, 4, for example, and it would check all those and give one response. In this case, this range indicator, at least with Swift, any value that falls in between. So we already picked up on the fact that it could be any value, right? And we're seeing it actually working. All right, we're going to move on to the next page here, which is another one of the app exercises. So this is one that would be submitted. We are going to go back to the fitness tracking app, as you can see. And it says, if you completed the target heart rate exercise, you show different statements to the user based on whether or not the user's heart rate was inside of a zone, right? Now you decide to just tell them what zone they're in rather than telling them what zone to be in, right? But, so in other words, like you're not going to tell them to speed up or slow down. You're just going to say you're in the high zone or the low zone or the, right where you should be. And you can see they've developed a whole range here, right? So you can kind of see where this is going, where they have ranges that go from 100 to 120, 121, et cetera, and then all of them have a message to match, right? So the beauty of this is the numbers are right there and the output is right there. So you can like literally copy and paste down when it comes to it. And here's what we're going to do now is we're going to write a switch case statement that's going to execute this. Now, what I've been doing so far, here in the exercises is we're coding this all together, right? So what I think that might be more interesting in this case is let me pause the video. I'm going to let you guys code this. Okay, so I know from an experienced coder standpoint, I can knock this out in like 3 minutes. It's like what my brain is saying, right? As fast as I can copy paste pretty much. And maybe your brain's not like that, but I assure you this seems like it's difficult, but it's okay. The only thing I'll have you consider is they have 5 ranges declared here, right? And then they have this thing at the very bottom, and I don't know if you guys are catching it, that says, if the current heart rate's above the listed zone, print some kind of warning asking them to slow down. So they do want a default in here. So this will be a switch case statement. I'm going to pause the video, let you guys work on it, and then we'll take a look at the solutions, and then I will put my complete solution on the screen rather than typing in manually right now. So I'm going to give you guys, I'm going to be polite, I'm going to give you guys 10 minutes to do it. But the moment you guys are done, just let me know, and then I'll resume. But I'm just going to sit here. I won't mute or anything. I'll be right here. So.
Okay.
All right, so we've taken a little bit of a break here to let everybody try to code through this. But I'm going to just drop the answer on the screen. Right? I just warned everybody that I was going to do it. So what we're looking for really is to take this, this provided information, and it's nice that they put it like this, right? And we start with a preset value, we're switching on it, and then we're setting up those ranges. So the same exact ranges you see here, we're just doing the dot, dot, dot in between. We're working with integers, so it's really straight ahead. And then they gave us the text here that we see up above. And once you get the format of this, it works really well. Now, one thing that you will notice, and most programmers will do it like this, is when they're doing ranges like this, and the ranges are kind of increasing, once again, like with if and else if statements, it's kind of nice to kind of have a systematic flow, like either going top to bottom or bottom to top, right? In this case, we're starting with the smallest values and going to the biggest. Well, there is a default scenario here too, because they're saying if current HR is above the listed zones, print some kind of warning asking the user to slow down. They put in a default statement, and I'm going to argue that maybe that was not correct. This is kind of an interesting thought, right? Because the default would also kick in if the heart rate is below 100. So what I would maybe do in that situation is I might set up a range that's maybe like I don't know, 60 to 100 to say, you're normal, or something like that. Or maybe a 0 to 60 or 0 to 59 range that says, hey, you're almost dead, wake up. Yeah, because if you had 99 as your heart rate and it would hit the default and it's telling you to slow down, right? And really it should be telling you to speed up. So this isn't perfect is what I'm saying. But the point is, most likely if you're working out, you're probably going to be over 100 anyhow, right? So this is the solution that the author had. So if you have something like this or similar to this, you're okay. The important takeaway is the ranges and getting the right responses. And of course, if the ranges are working by changing that current HR number to something that's appropriate. And then, try a real large value or a really small value and see how it lands. What I will tell you though is if I was in a situation, so if I wanted to put in a case of like a low range, I can't use any logical operators with it. That's kind of, so I can't do truth statements in a case statement. I can only evaluate the value of the thing we're switching on. If it's a number, it can be in a range. If it's a string, it's got to match, right? We saw that floating point numbers work within a range too, right? So that there's a little bit of flexibility here. Is this perfect? No, but it puts you in the right range, right? And it's practice with the case switch statement. And this is really important, especially when you have a lot of scenarios that you're accounting for. And, this is like what, 5-6 scenarios. Can you imagine if you had 100 scenarios, right? And this is the easier way to do it than writing else if statements. No curly brackets to worry about in between. You just do it. So that was this exercise. We don't have much left here, so let's finish this off. The other one that we teach, right, and this is kind of a modern coding thing here, is this thing that we call the ternary operator. And let's look at the scenario here, because you guys might not even remember what that is, right? Because I think we looked at it for like 10 minutes and then stepped away, right? And basically, we have two constants here, number one, number two. Then we're checking to see which one is the largest. So we're doing comparisons. If number one is greater than number two, then the largest number will be number one. If it's the other way around, then it's number two. It's either one or the other, right? And very often when we do if statements, they kind of fall into this pattern. It's like, hey, if this is true, it's this. Otherwise, it's this, right? And so what they did is they came up with a new way to do an if statement. And what they want us to do here is, instead of using this approach, they want you to comment this out. And if I always forget what the shortcut key is for doing this, but I think it's like Command Shift / or something like that to comment out a block of code.
You can
And-
highlight the whole thing in this command.
Yeah, let's try that. So is it Command Shift / No,
Just command forward or command slash.
/ yeah. So if you do Command / it comments it all out at once. But they're giving you the if statement here as a point of reference so that you can replicate it. So instead of creating this variable called largest that's going to hold the value, I can create a constant. So this is kind of a double win here because now we're creating a constant instead of a variable. And what we're going to do is here's the ternary if statement. We put in the thing that we're checking for true and false, and that would be number 1 being greater than number 2. Is the first number greater than the second? If that's true, right? So this is kind of how it reads. So notice the question mark. Then it returns the number 1. Otherwise, or else, it returns number 2. So this is a ternary operator, or the kind of like the sleek shortcut way to do if statements these days, right? And we call this a ternary decision statement, and they're calling it a ternary operator. But basically the layout is statement we're checking for true or false, just like a regular if statement like you see up here, right? And then the question mark, what happens if it's true, the else, and what happens if it's false. Now, these are limited, right? So I can't have multiple statements inside the true or false part. I have one thing I'm checking, and then it's going to either execute an action or return a value. That's either one thing or the other. This is super efficient though, and what a lot of programmers are switching to when they have these really simplistic little if statements that they're writing. I mean, notice the amount of lines that you're saving here. I mean, even trying to be efficient here, we got 6 lines of code, right? This is 1. The other efficiency that's gained, and this is one that you might not see right off the bat, is if I was doing this approach up here, I have to set this for a variable, which increases the memory footprint because we don't know how it's going to evaluate. It could change, right? That's the whole thing. Here, because it's going to be one or the other, and we know it has to be, I can then put it in a constant. So I'm like saving even more memory, so there's that efficiency that happens with it. All right, so we're going to get a little more practice with this. So we're going to move on to the app exercise here as we wrap up. I'm going to do this pretty quickly because I do have to bump out to a meeting. So the first thing that we'll look is what the logic is. So it says here that we have step goal of 10,000 and the steps are 3948. And then we're checking to see if those steps are less than half of the step goal, we do the almost halfway thing. Otherwise, we say over halfway. I am going to comment all of this out. So we'll use the trick where we highlight it all and then do command / I'll do a comment. And we're just going to switch it to a really quick ternary statement, but I'm not going to assign it to a variable, right? This time I'm just going to print it, okay? But we're going to take that. So in other words, I'm going to write a print statement, nothing inside of it, and then I'm going to put my ternary operator or ternary message inside here, or option for ternary message. We'll put in the same logic. We're just going to say steps equals less than step goal divide by 2. So we're still doing the same logic check. Here's our question mark, which implies the if. And then what are we going to say if it's true? We're going to say almost halfway, right? Otherwise, or else, they've gone past that point. We're going to say over halfway. And that's the whole thing. There you go. See how like painfully simple that is, but the practice here is converting a simple if statement that's got one action inside the if and one action inside the else. We're converting that to a ternary statement. And you see how like nice and slick and clean that is, right? It's inside of a print command. So when it's returning the string, it's inside the print command. So it just prints it, so kind of a neat little clever way to do it. So I like this approach. And once again, we're going from 5 lines of code down to 1, right? And directly to the output. So very efficient. All right, folks, we are going to have to call it here. So I'm going to hit the stop button. So we did finish this next playground here. So we did get some good work done today. So this video will end here.